Hey everybody, decided to try and squeeze this video in quickly today as well. Let's take a quick look at the Lab 7 Reverse Engineering. I've just previously recorded the lecture for this week, so it should all be relatively fresh and I'll be making some correlations across. But this week we're going to be playing entirely within our Kali Linux virtual machine, so you are not going to need your emulator or your Android virtual device for this week. So the subject of this week's lab is reverse engineering. So we're going to be installing a few more tools into our Kali host operating system, and we are going to be doing some analysis of the Insecure Bank version 2 application that we were looking at last week. So to kick things off, I'm first going to install these new tools. There's a couple of ways of doing it, but I'll kind of go through both of them. The first way that is shown in the description of the lab is just by typing in apk tool, being the specific tool that we want to install, and hitting enter. Here you can see that it's prompting us, hey, do you want to install that? So we can hit yes. It'll prompt me for a password. And now it's installing. Oh, prompt me one more time to make sure that I want to install everything. And while that's going, I'm just going to, oh, never mind, it is already done, but you can see there's some errors here. So if you come across these errors, we're going to do the second technique for potentially installing these. You're going to do apt space update. You're going to want to put a sudo in front of that, sudo. Sudo apt update. And that will update all of the repositories that the operating system uses to download these tools from, so that we're just making sure that we have the latest and greatest versions available. This doesn't typically take too long. It should be finishing up in just about a second here, and you can see there's a lot of stuff to upgrade. Typical good practice, you want to upgrade these as you go, but since this is a lab environment, it's not as critical. So once again, we're going to type apk tool, and then we'll go through those prompts. This time it doesn't prompt me for a password because I've already authorized it, so I will say yes to installing it twice. Give that a second while it downloads everything and gets it all ready to go. So while that's downloading, I'm also going to open Firefox so that I can get a copy of the APK file that we want to use available on the host for me to play with. So first thing I want to do is make sure that my proxy is turned off so that I can actually access the internet without burp running. So I'm going to turn that off up in the corner over here. And then I'm going to paste the link from the lab description and download the Insecure Bank version 2 APK file. So we've got that downloaded, and we can see in the background that our installation has finished. So I will show you the other method of installing the second tool we are going to need, which is similar to what we just did for updating. We're going to type apt install instead of update JADX-GUI. And in this case, I like to put a -y because then that removes one of the prompts that says, hey, do you want to install this? Oh, I apologize, I forgot to do sudo again. So we want to run this as a super user. And you can see that the error message here, unable to acquire the front end locked RU root, so it tells us what our mistake was there. So adding that sudo, alright, let's install it that way. Okay, so the JADX GUI is a component of the JADX suite of tools, so that's why it didn't install properly. So you can install these either way. It's probably easier just to type in the name of the command as it is outlined in the actual in the quiz itself. So now our current state is we have our APK file, and we have downloaded and installed our two tools that we're going to be utilizing today. So we are going to now go to the folder that we have our APK file located at. Since we just downloaded it through Firefox, it should be in our downloads folder, which we can confirm by just viewing that from the download manager. If you click the little window icon or the little folder icon to the right of the file, that will show you the location of the file in the actual operating system. And you can click up here to see the full file path available. So we want /home/Kali/downloads. So in this particular case, if I type pwd to print my working directory, I can see I'm already at /home/Kali. If I ls-l, we should be able to see that there is a downloads folder. So let's cd into the downloads folder. We're going to do an ls-l to verify that our Insecure Bank version 2 APK file is available. So as I covered in the lecture briefly, the APK files are a zipped archive, basically. There's multiple files within it that are all just zipped in, like with our CyberChef file here, where it's a .zip file. So we want to unpack it and take a look at what's going on. First thing I want to do is make a new directory, which I'm going to call unzipped, and this is where we are going to extract all of the files contained within Insecure Bank into. Next, we're going to run the unzip command, and we're going to point it at the Insecure shop, /insecure bank version 2.apk, and then I'm going to supply a -d flag and the unzipped folder that we just created. And here's a lot of output. This is just all of the different files contained within the actual APK file being extracted. So now that we have it extracted to that folder, let's go to that folder and take a look at what's going on. So I'm going to do an ls-l to take a look at what's available, and we can see our Android manifest, classes.dex, our meta.inf, our resource folder, and our resources.arsc. So as good penetration testers or good security-minded people, we're going to want to take a look at the structure of the application first. So to do that, we're going to have to look at our Android manifest. So if you recall, we used the more command previously, so we're going to type more Android manifest.xml. And that doesn't look like XML data. What's going on here? Well, if you need a little bit more insight about what's going on, you can always run the file command, which would tell you the operating system's best guess at what content is contained within that file itself. Apologize, I thought there was a cat behind me. Turns out he's right beside me. So I'm going to do file Android manifest.xml, and we should see, oh, okay, the answer that we're looking for here is that we are looking at a binary XML file. So we're not looking at plain text XML. So that means we're unable to read it flat out using just text-based editors, which isn't the end of the world. We will notice, though, that in the unzipped content, we don't actually have any code. We've got, let me clear and ls-l. There's no source code files here. There's a classes.dex, you've got your meta.inf. If we look in there, ls-l, meta.inf, then we see a .rsa file, a .sf file, and a .mf file. These are our certifications, our signature info. We have our res folder, which contains a lot of additional folders, but these are mostly visual resources. So there's no actual plain text human readable Kotlin or Java source code available. The closest thing we have is our classes.dex file. And we can see that is a Dalvik dex file, version 035. So what does this file contain? That should have been answered in the lecture if you watched that, and that is one of your questions coming up in the lab. So this is sort of a shot in the dark type of a method of analyzing, where we have extracted the file and now we're manually looking through the data to see if there's anything useful to us. The XML file we can't see, currently we cannot access. The classes.dex file is garbage. If I try and output that, then we can see, similar to when we were trying to view the Android manifest, it's not human readable code. This is our bytecode that the operating system knows how to handle. So let's take a step back. I'm going to change directory up into the downloads folder again. And this time, instead of doing a manual approach to analyzing this, let's decompile the application to Smalley and see if that shows us any more interesting information. If you remember from the lecture, Smalley is an intermediary language that can take the Dalvik or the DEX files and turn it into human-readable source code, but it's not something that people typically develop in. It just makes it easier for us to understand what's going on inside of that DEX file. So using APK tool, which we just installed, we're going to add the D, which is a flag required for our specific need here. I'm not going to cover the full scope of the APK tool, but if it is something that interests you, I strongly recommend you take a deep dive yourself, and there's lots of tutorials and sort of information available online about this tool. So we want to specify our insecurebankv2.apk file. And we're going to let this run. While this is running, it's going to create a new folder for us, which I can now show you, being the Insecure Bank v2 folder. Let's enter in here and take a look at what's available. So it looks pretty similar. We have our Android manifest XML file. This time we have an apktool.yml file. We've got an original folder, a resource folder, and a Smalley folder. So similar to before, we want to kind of know what's going on, so let's take a look at the Android manifest. If I do a file, you can see this time it's not a binary XML document. It is a XML version 1.0 document with ASCII text. That means we should be able to actually see the content in our XML file now. And there you go. Now we've got lots of content available. There is a question in the the lab that is based on the content within this XML file, this Android manifest. So you're going to have to kind of look through and find a little bit of information, specifically which component is not exported within this Android manifest file. So when you're done looking at the manifest file, I'm going to clear the screen just to make things nice and clean again. I'm going to ls so that I know what's available. And I'm going to now take a look at some of the Smalley code. So let's change directory into Smalley. In this case, I'm going to go to com android insecure bank v2. And if I do an ls-l again, here we should see lots of Smalley files. $raw.smalley, $string.smalley, styleable smalley, style smalley. We've got login activity $1.smalley, login activity smalley. So there's lots of kind of custom code that we are now able to kind of take a look at. Let's take a look at this do login.smalley file. So I'm going to do another more do login.smalley. And here is that short form, sort of more human readable, but not necessarily codable format that I was discussing, where we can see some static fields that are defined. We can see some instance fields, like there's a remember me password, remember me username, that's a string. We've got some annotation for member classes. If we take a look at a different file, let's go with do transfer.smalley instead. If we kind of scroll down, there's lots of source code available. Like here is some methods. We've got our constructor available here. We've got some access functions, and there's lots of available sort of intermediary code here. So it's possible for you to understand what's going on, but not necessarily intuitive enough that you can just code like this. If we wanted to gain access to some lower level source code, then we would need to decompile this instead of disassemble it. But before we get to that, we are going to take a look through this for one other thing that we're going to be looking at in the Smalley thing. The Smalley output here. Sorry, I just had a major brain fart on how to speak English for a second. So one thing that we're going to want to do is try and identify any hard-coded secrets that might be available in this or inadvertently exposed. So while you could do what we were just doing of stepping through all the Smalley files and looking manually for stuff, it might be more appropriate to take a shortcut. Here you have a research-based question that's asking you to, using either your own Linux skills as they exist already, or to use Google to try and assist you here. Try and identify the word secret within the Smalley application. And if you find secret, you need to just copy and paste what the full value of that secret string that you identified was. I'm not going to show you that one because I want you to research how to search for content within files on the file system. So that previous issue, though, of that secret hard-coded in is the result of a hard-coded secret being used for encryption operations. So there is a question that will kind of make you think back to our cryptography lecture and our permissions lecture, but why is this a bad thing? Why is it not good practice to have encryption keys set in the source code hard-coded? And that brings us into the final tool that we were going to look at. We want to decompile instead of disassemble now. So we're going to examine a quick representation of the Java and recall that this is a lossy operation. We're not getting the true original source code, we're just getting something similar to that original source code. So we are going to return back to our downloads folder. To save time on this one, I'm going to cd a squiggle icon /downloads. That squiggle just means your home directory for your user, which you can actually see right there as well. It's just a shortcut instead of typing cd/home/Kali/downloads. That's the exact same thing. So now that we're in the same folder as our APK file, we can confirm that with an ls-l. We want to run that JADX GUI tool. So JADX GUI. And we'll give it a second for it to actually open, and we should be presented with something like this, where it's sort of a new project screen. This is a Dex to Java decompiler, and this specific application provides a GUI for you to work with. If you don't want to play in the terminal, then you don't have to play in the terminal. So we're going to go File, Open Files, and we're going to go to our Downloads folder and select our insecurebank.apk. Now it's going to perform some analysis. Oh, I apologize, one sec. Apologies for that. So now that we have this open, we can actually use this like it's an IDE to explore the application. It will have decompiled everything to the abstraction, or the close enough Java that it would be able to work. So you can see on the left-hand side here, we've got our source code tree, and that allows us to navigate down and see some actual Java source code available. You are asked for your last question within the lab to analyze this crypto class that should contain that secret key that we hopefully identified earlier using our searching skills and our Linux skills. But you can see that this file is significantly easier to sort of make sense of as compared to, say, let me open a new terminal to give that example. If I do more, downloads, insecure, smalley.com, Android, secure bank, and cryptoclass.smalley. So I will minimize that so it's not in the way, but you can see this Java source code makes a lot more sense than this Smalley kind of intermediary code. While we can make some sense of this, this is much easier to us developers who are accustomed to using Java to navigate. So this tool is actually able to take things a step further and utilizes names of variables that convey their use or purpose. That is extremely uncommon in this type of tool, but this will allow you so much more flexibility to explore and manually, statically analyze these applications. I strongly recommend you play through with the Insecure Bank version 2, or I apologize, the JADX GUI tool. I'd recommend you take some of your existing APK files you might have made in other classes and bring them into this tool. See how they compare to your original source code and just play around with it. See what information is available and how your DEX class files gets translated back into Java source code, or even better, if you were programming it using Kotlin, try using an APK that was developed using Kotlin and see the Java that's spit out. These types of tools give a penetration tester an insane amount of information and a great starting point to work on these security issues. So that actually covers everything for this lab. It's a nice quick video this week. And yeah, I hope that you are able to take some extra time, because I know this is about 20 minutes instead of the usual hour. Take that extra 40 minutes, play with the JADX tool, use your own APK files, find some online, pull some from your phone, play around with it a little bit, and just explore the tools, because these will provide you a lot of information, and it's a great resource for trying to identify if you find an application that does something cool, you can see how they do it. So I'm going to leave you here at that, and I will see you guys next week at the time of this being released. So have a great weekend, everyone, and I will talk to you soon.